This is the third video in my series on using Google Sheets to do inferential statistics by running simulations, hopefully a more intuitive method than simply doing a t-test. Although on this video, we are going to simply do a t-test so we have some way to check it, whether or not we got the answer right. On video 1, we took this data from a survey back in February of 2018 called Pulse of the Nation, and we looked at two questions: whether people approve or disapprove of how Donald Trump is handling his job as president, and how many times people think Donald Trump has been married. In the first video, we simply took that data and we did what's called scrubbing it. We cleaned up all the answers that didn't make sense or didn't fit neatly into one of those two categories, approve or disapprove. Answers like people who thought he'd been married 100 times. And we found the average number of times that people who approve of Donald Trump think he's been married, 2.68, versus people who disapprove, 2.91, for a difference of 0.22 marriages. For reference, the correct answer is 3. In video 2, we then saw if we could create a difference that big by simulating the null hypothesis and randomly assigning the number of marriages to the number of people. We created this copy over here, and we randomized the range to randomly assign people's estimations of marriages to the people who approve or disapprove to try to generate a difference of 0.22. And as you can see right now, that's not working really well. We're having a very hard time getting a difference that big. Apparently, that difference is hard to generate due to randomness, which suggests that these results are what's called statistically significant. Now, we're going to actually run a t-test. That will give us what's called a p-value. The formula for t-test is, ready for this, t-test equals t-test, open parentheses. First, we're going to plug in the range of people who approve of Donald Trump, which goes from box, not A2, box B2, down colon to box B239. So you scroll down, you can see that's the last person in this survey who approved, comma. Now I'm going to do the second data set, the people who disapprove, B240, colon, all the way down to, B240, all the way down to the end of my data set is B574, colon, B574, comma. Now this is going to seem really arbitrary from here. The next thing I want to type after that is a number that represents the number of tails. We're always going to use 2. One-tailed tests are a little bit of a special case that we're not going to get into. And then the type of test, which you have to click on this to see what the options are. We want not a paired samples t-test, but just a basic 2 sample where we assume the variance is unequal because each of the 2 groups has a different variance. So we want type 3, which for now is all we're going to use. We're not going to get into type 2, although we will eventually do a video on type 1. Hit enter, and we can see that the actual probability of getting a difference that big, simply due to randomness, due to the null hypothesis that this is random, is 0.00006, or that would be 0.006%, which is less than 1 in 10, 100, 1,000, 10,000, less than 1 in 10,000. It's about 1 in 20,000. We probably would have had to do 20,000 trials before we got a successful trial. So we can say we reject the null hypothesis. It is definitely the case that people who approve of Donald Trump have a lower average estimated number of times he's been married. Also, another way to put that is a less accurate estimation than people who disapprove.